We're all too familiar with the unsubstantiated claims of fraud leveled in the aftermath of the 2020 election. The allegations sparked dozens of lawsuits and audits, as we've heard here earlier today. But what exactly constitutes fraud? And apart from the partisan noise, is there a legitimate way to detect election irregularities? Walter Mebane is a professor of political science and statistics at the University of Michigan, who uses election forensics, a combination of statistics and political science, to diagnose election fraud. Professor Mebane also is a member of the Election Verification Network, a nonpartisan group of experts dedicated to ensuring transparent, accurate, and secure elections. Please welcome Professor Mebane.
Thank you, Kevin. Is this on?
Yeah.
Okay. So election forensics is the name of my primary research project. It's a phrase I invented in around 2006, thinking of the stuff I was doing at that time. I thought maybe it would be a TV series like CSI, where they make chemistry, DNA interesting, so maybe we could do that for elections. Don't quite have that yet, but we're getting closer than we were 20 years ago. Election forensics, I'll give a definition of election forensics in a second. Let me see, this is the slides, all right. So I'm going to mainly end up talking about statistical work, which I've recently, this is like bringing what I consider the state of the art of election forensics, just the latest thing I happen to be working on. I'm working on a very long book, hopefully finishing in the next few weeks, called Election Forensics, maybe with some other stuff about a particular method called e-forensics, which again, I'll tell you more about in a second. But let me set the context for these remarks by saying that election forensics is in the context of more general interest in election integrity, and security is a part of election integrity. Just to keep the phrase level, you could think of the election integrity as involving the notion of free and fair elections, and maybe when to say the elections that have the correct outcomes. The free and fair elections part, I cite here a book by Pippa Norris from 2014. My last slide here will have a list of all the references if you want to see the actual references to the materials I cite throughout the talk here. And she has a comprehensive list, not only in scope of the United States, but around the world, for what it takes to have elections that have integrity. Election systems vary a lot across countries and parties and candidates and election rules and everything else. Campaign finance, suffrage, varies a lot. But the notions of what it takes to have election integrity, maybe free and fair captures that, maybe it doesn't, but see her book for a very comprehensive and I think excellent review of that kind of material. Having correct outcomes is a bigger issue. Back in the 2000 election, when I was shocked to realize that there was no science to be able to tell whether an election had a correct outcome. Recall in that case in the United States, we had a presidential election where George Bush won. Just to give you my sense of where that went, I wrote a paper called The Wrong Man is President. So that's kind of what I think happened there. And I wrote a couple of papers about that. But in the course of doing that, I discovered there was no science. The last work on election was basically from 1934. And so since then, basically, I've gradually worked more and more on this. And for the last 20 years or so, election forensics has been my main project. I think about frauds particularly, and there are two classes of frauds that may be useful to think about. All right, so the idea of frauds is interesting, and in fact, defining frauds is kind of complicated. I'll give you my explicit definition of what I mean by frauds in a couple of slides. But there's lots and lots of work on what I'll call procedural frauds, because these are easy to observe. This is, you have a process by which the election should occur, starting well before the votes are cast, to the nature of the campaign. Are you arresting the candidates? Are you killing them? That's probably not good. That happens in some places. No, it's definitely not good. I won't put it on that. Are there very long lines? Are the forms filed? So all these things where you can see things happen and see whether they're done right. And those are often places where you can spot things being done wrong. And there are many books and articles about monitoring for elections procedural defects. So those are procedural frauds. Those don't necessarily get at whether the election has the correct outcome, in my view, because you want to know whether all of those activities change the way the votes would have been counted. So the realized frauds is a phrase I've come up with, and you can let me know whether it doesn't really work, which is, is the outcome adversely affected by malevolent distortions of electors' intentions? And the malevolent means some intention that's designed to produce an outcome that is independent of what the electors. Electors, I mean voters or eligible voters, registered voters who may choose not to vote, but they're still counted as that's a decision people can make. So if you have a choice that's made to just impose an outcome, whether or not, okay, is this better?
Yes.
Okay. Impose an outcome, whether or not you're a bad person, that's not a general malevolence, it's about that. So I'll say more about this malevolence in a second. You can also have accidents that cause elections to go wrong. And part of the diagnosis you want to do statistically and otherwise is try to see whether something happened is due to incompetence as opposed to malice. All right. So let me see, this one is to go forward. So how do you get evidence about this? And of course, we have election denialism in the United States in recent years. And so these are claims made against all facts and all evidence. But what kind of evidence that those of us who live in objective reality think is the kind of thing that would count to argue for or against the credibility of an election? Just to be clear, my design is not to find frauds really, but to have evidence that elections have the correct outcome. I'd love to find that. But of course, the opposite of that could be in part finding these malevolent distortions. So observers there's many international and domestic observer groups, and they go around and they're especially good at finding procedural defects. Think of the Carter Center and other kinds of groups like that monitor elections. So observers of this type have systematic ways that they do this kind of monitoring activity starting well before the election and going through the counting process and even through the installation of the government. So that's one kind of evidence, mainly about procedures. Sometimes these observers collect data about the votes and use some of the other techniques, but mainly they're there to monitor the process, election violence and things like that. You could have public opinion surveys, though these usually come in pretty late. And I want to distinguish here exit polls, which are, in the United States at least, are not at all useful for evaluating whether an election has a correct outcome because of their design. Some other countries have exit polls that they call sometimes that are a little better at this. But these are surveys done where you ask voters, do you think the elections were trustworthy? Do you trust the election outcome? This is great, but it usually comes much later, like a year or two later, and it's only a small sample. So it's not really useful for diagnosing frauds or allegations during the period when it matters for making a difference. There are challenges often brought by parties or candidates, and these are litigated usually through some kind of a court, the general court system or special election courts. American courts are quite complicated, as you all know, but you can have challenges that come through the courts. And these often then mobilize evidence by experts, which are advocates for one side or the other. And the judge maybe has to find what the truth is in there, if it's not there at all. But that's one source of evidence developed in a rapid fashion. You can have a recount, sometimes a normal recount if the election is really close, it's just triggered by state law, or people can have this as part of their challenge. And I'll say a little bit more about a version of these recounts that's not a full recount necessarily. The last category is one I mainly want to spend the most time on in this talk, which is other statistical approaches, which is the kind of work that I've done, where you work with aggregated data. By aggregate data, I mean you don't have individual ballots. You can't have that from a couple of states like Florida, but generally you don't have that. So you have aggregate votes like precinct tabulations, or for other countries, polling station aggregations or ballot box aggregations, totals at the ballot box or precinct level. And you know the number of eligible voters, which could be the same as the number of registered voters. And you also know votes cast for each candidate or party and the number of votes cast overall. Okay, so working with just those kinds of data, maybe some other information you bring in, I try to develop, others also work in this area, to develop statistical approaches to address the questions about fraud or accuracy, lack of fraud. Okay. So here's my definition of election forensics, the first bullet point on the slide here. Election forensics is using statistical methods to determine whether the results of an election accurately reflect the intentions of the electors. And this is a rich sentence that I could talk for a couple of days about, but I'll just mention that while this is a target of empirical study, because I'm an empirical political scientist and statistician, so I want to get data and have some usually models to try to estimate some values. So I'm really wanting to measure these things. and to list the things that are not observable. Usually you can tell who the electors are, who the eligible voters are. You can't tell their intentions at all. You have no idea what people want to do. Even if you can discern what their preferences are, you have no idea strategically what they decide to do. Maybe people are voting for their second or third choice because they don't think their first choice has any hope of winning. So intentions are kind of hard to observe. Accurately is trying to see the mapping between their intentions, which you can't observe, and the outcome. And then the rest of it's okay, except you remember the previous slide I talked about malicious distortions. We can't measure malice either. So this is a little bit challenging. It's a question for those of you who like statistical terminology. This is a big latent variable problem because the main thing we want to discern is not directly observable. And this has made the focus on procedural defects or procedural frauds explainable, because then you don't really have to do any of this fancy stuff. You just have to look and see, no, you did not fill out the form correctly. No, you used the wrong kind of pen. No, you didn't fold the ballots. And so those things are easily observable. Intentions of the electors, malice, hard to say. Okay, but I've gone down this path. So in general, I say there are three kinds of statistical approaches. They're overlapping and they're not really mutually exclusive, but they're kind of distinct. And I'll talk about them sort of separately. One is to identify patterns that, to use a technical term, look weird. That's in the eye of the beholder, of course, but there are certain standards that people have suggested for what not weird looks like. And I'll show you a pattern that looks weird according to prominent researchers. And this has been interpreted by many to indicate that there are frauds. And you can be more or less impressed by this when I show it to you. But I'm also going to immediately say this has a little bit of a difficulty, okay? But that's been a lot of the game, not trying to actually measure frauds, but just say, you know, that doesn't really look right, so fraud, okay? The second kind of approach is to actual test, statistical tests, which could be formal kind of tests. And this is usually a distinction between hand counting of paper ballots, which is taken to be among the best methods to determine whether the intentions of the electors are accurately conveyed to the aggregation system, the tallying system. If a voter hand marked their ballot, presumably they did that to accurately say what they want to do, though people do make mistakes. And then you want to see whether, say, if a machine counted the ballots, like an optical scanner or entirely electronic, you're kind of hosed. But then you want to test whether the tabulation method gives you the same answer that a hand count would have done. Risk limiting audits are one way to do that, where you have a statistical method that tells you when you need to stop hand counting, and it could progress to an entire full manual recount if you don't get a satisfaction of agreement between the manual tabulation and the automated system. I think you heard a little bit about that before. Michigan had that system used a bit. I saw the Secretary of State's on. You can ask her about how Michigan implemented that if that's something he wants to talk about. Parallel vote tabulation. I'm kind of involved in that going on in Venezuela right now, where if you read the Times or Washington Post stories about it, they said they didn't, at the polls, let people have the tally sheets at the polls, which is a way of checking whether the paper record of the votes at the polls matches what the central government reports about the election outcome. So I'll see over the next couple of days whether we have enough information reported to handle that. But those are kind of discrepancies, and those are not really general kind of frauds, but just is the tallying correct between the automated or central reporting system and the manual recount. Many other ways of distorting elections besides just manipulating the tallies. The third category is estimate directly the presence of what I'm calling frauds, and I'll explain why I have frauds in quotes in this sentence here. How many precincts or polling stations, I'll use precincts as a terminology unless I'm talking explicitly about another country, which I will in a second. How many precincts have frauds? And then even more challenging, how many votes are fraudulent? Okay, so I'll just tell you, 10 years ago when I started this, I thought it was completely impossible to do that third thing. But now I have a technique called e-forensics mentioned in the last sentence that I think does that. So it's a miracle, and I'll persuade you. I mean, I kind of understand how it works, but I'm astonished. 20 years ago, anyway, let me move on. I don't have much time to gush about this in my own work. And it's not perfect, I'll just mention. I'll show it's got many limitations, this work. Okay, so let me talk about anomalies first, because people often, when they're going to be modest, and I had an argument with someone at a conference last week, I talked about my method, and he said, oh, you have anomaly detection. I say, no, we do more than that, but there's a fight to get me not say I'm measuring frauds. So they say you're finding anomalies again. I think I'm doing better than that, but I'll show you and you can believe it yourself or not. So anomalies in aggregated vote counts, like precinct vote counts, suggest, or maybe some people claim, indicate that there are frauds. And there are many ambiguities. I think these interpretations are unsound, but sometimes they're strongly argued. So I'd say there are roughly 4 different categories. Again, these are not perfectly mutually exclusive. This book by Madkov, Ordershuk, and Shakin from 2009, again, I have a reference at the end of the slides here, has this phrase, fingerprints of frauds, which is used in other authors' work. And their view is you make a plot of the data and poof, you can just see this fingerprint. It's right there before you. Sometimes you do a little light statistical work, but you can basically see it in the data. And I'll show you an example of this, and you can tell whether you can see this in the data. And you should say, ooh, ah, when you see it, okay? So that's one kind of method, and that need not necessarily use precinct level data. In fact, their book does not use precinct level data, but use slightly higher level aggregation. I won't get into the difficulties of aggregation level because I don't have time, but it's important to use, in my view, the lowest level of aggregation you can get: precincts, polling stations, voting machines, ballot boxes. Digit tests, I spent a long time working on digit tests. My colleague Alan Hicken and I wrote this report for the USAID grant we had about various kinds of digit tests. I spent a long time working about something called Benford's Law. So sadly, it doesn't work. It's too ambiguous, but it's often cited. Vote share test is kind of related to digit tests, and I won't say much more about this, but Rosenos has a nice paper. Again, it's a version of you look at the pattern in the digits in vote counts, and that tells you there is fraud, is the claim. So he has a statistical way of assessing that. The last thing is there are a bunch of nonsensical claims made by crackpots. And so I haven't spent time talking about them that much, but my colleagues, Eggers, Garrow, and Grimmer, you can find one paper published in the Proceedings of the National Academy of Science, and that will go through a lot of these nonsensical claims about 2020. And Justin Grimmer and Michael Heron have another forthcoming paper about more crackpot claims, so you can see some of those. So especially for journalists, it's probably good to review this paper and their more recent one just to see the way they unpack and take apart some of these claims, which are essentially nonsense, okay? And so here's where you're supposed to say, ooh, ah, but wait a second, I'll tell you what you're ooh and ah about. Okay, so here's an example that is cited by some prominent researchers, Peter Klimek et al., that I'll have a citation to in a couple of slides. And they're using the fingerprints of fraud language. And this is for an election from Uganda in 2011. And they say you can just look at the data. They show a slightly different representation, and the histograms really barely showed up here. In the x-axis, you see this little blue histogram at the top, and on the side, can you see that? Barely. If you're colorblind, you can't see it, and it's really light. But this one is kind of bumpy, and this one is kind of there. But the main part is this collection of points right up here, and there's a little peak right there. So this kind of peak right here, and then a second peak right there, or this peak here, and this peak here, and this concentration of points here, and the big blotch here. These are called multimodalities in the data. And that there's not a point that's the most frequently occurring point that's a single one jointly for turnout, which is along the x-axis here, and votes for what I call the leader, the candidate who got the most votes, which is Yower in this election. And that's along this axis. These are proportions. And if you just had a unimodal distribution, it would have like a peak right here, where it's all blue because it's a two-dimensional density, but it's got this extra peak right there. That is one of the fingerprints of fraud. It says Peter Klimek et al., it says Myakov et al., because that indicates that you have this, well, multimodality, and they say that's fraud. So let the room say, ooh, ah. Okay, so there are book links, treatments of this, and so I'm not going to go on about it more than to say, yeah, I thought that was plausible for a long time, but I've learned that there's a big problem with these fingerprints, and especially if you remember you're a social scientist or political scientist like I am, or even an economist, which I'm not, they often are concerned about things like variations across localities in the political support for parties and candidates, as well as the degree to which different areas participate. So you can just imagine, I don't know if anybody knows about Uganda here. Anybody know Africa much? Okay, I can say anything. I don't know much about Africa myself, but I do know there are tribes and other kind of localities that are very strongly supportive of one candidate versus another candidate. So you'd expect to see great variations, not only along this axis for the support, but also in turnout because they're more or less mobilized. So a conventional method is to try to control for these variations in localities of basic support for her trying to identify whether something's unusual or odd or weird, right? And so one way to do that is to so-called control for fixed effects for geography. So one way to do this in the data I have here from Uganda 2011 is to control for the province that they have. And so when you basically remove the mean turnout in each province and the mean support for this leading candidate in each province, and show the residual proportions. Oh, here. What happened to the fingerprint? This is why I call this a brittle anomaly, because minor applications of just very basic social science knowledge or political science knowledge about the complexities of elections can mean that these anomalies go away. And generally, in the development of many of the anomalies, if you look at all those papers, some of which I participated in, contributed to, they are just looking at the raw data essentially and not doing any adjustments at all for even basic facts about the political environment. And so this one, the fingerprint going away, is kind of an oh my God thing. There's a complexity of maybe you're controlling for the frauds and so forth, and we could talk about that if you're interested. But remember this plot because I'm going to show you that e-forensics works even if we've gotten rid of the fingerprint. And so that's I was scared that it wouldn't, but it does, and so now I'm proud of it. Okay, so like a kid at a rehearsal I don't have a kid, I don't play music, so I won't do that. Okay, so let me talk about estimating the frauds, which I spent most of my time on here since 2019. So that's the last bullet point. So I was inspired by this finite mixture simulation from about 2010, 2012. It was published by Peter Klimek et al. And this was a way to not just say there are anomalies and it's weird, but to actually estimate how many frauds there are in each precinct. And they didn't really get at how many frauds there are. They just were trying to get at the probability of fraud. And they didn't really have a statistical method. They had a simulation method. But I was really inspired by this approach, and I have adapted it to skip a couple of steps. My other colleagues from Caltech did this. Oops, the wrong pointer. Did this method where they used a classification approach to estimate frauds in Argentina 2015 election. I won't say more about this than to say I don't really think this works exactly. And if anyone's interested in Argentina, I can talk more about why it doesn't work, in my opinion. But this e-forensics thing, e-forensics stands for election forensics. Just to know what the E is for, this is a phrase invented by my former grad student, Diogo Ferrari. We had a National Science Foundation grant, which ended in 2019. We developed some code. This here is a reference to, you can find the code online if you want. Here are a couple of working papers that kind of come from the book manuscript that I'm hopefully finishing in the next few weeks. But this is a finite mixture model that applies Bayesian methods to actually give statistical estimates for frauds with full precision, confident, credible intervals, all that rest of it. So let me show you a bit about that. The rest of the talk pretty much is about e-forensics. Because I think it's not perfect, but it's, oops, wrong one. Sorry for the person I just blinded. So here's what e-forensics estimates. It estimates lots of stuff, and there's way more that I can fit into basically 15 minutes or 10 minutes, however much time I have left. Okay, I don't know how much time I have left. That's not showing my clock. Oh, yeah, I've got say 10 minutes left. All right, so e-forensics estimates whether each precinct has frauds in quotes, and I'll explain why it's in quotes again, and then give me another couple of slides and I'll explain why. And it tells whether a precinct has frauds, it may not have frauds, and if it does identify it as having frauds, it estimates how many votes at that precinct are fraudulent. Okay, so, and the only data it's using, by the way, is the count of the number of eligible electors, or registered voters, which in the United States you usually have that, the number of votes cast, and the votes cast for a particular candidate you pick, say the candidate with the most votes. That's it. And it gets all this from just that. So there's a mathematical model behind it. I'm not going to show you the math, but you can look at some of the citations to see the full model if you're interested in the formulation. So what does it produce? It produces essentially two quantities for each precinct. So in these bullet points here, down here, I'm indexing the individual precinct by the letter I, or polling station or voting box or whatever you have for your aggregation unit. I'll say precinct again in words here. And so F sub WI is the thing it estimates, which is the estimated number of e-forensics fraudulent votes. I use the phrase e-forensics fraudulent or e-forensics fraud just to refer to the kind of fraud that comes out of this model. And it's a research question whether that kind of fraud is related to malevolent distortions of elections intentions. It could be just something the model makes up and it's all nice and everything, but it's unrelated to what happens in the world, and no one should take it seriously, but I've tried to work hard to see that it actually is valid in the sense of it measures what we want to measure, even though it has imperfections. And I'll walk you through some of the examples of why I think it's valid over the next few slides. But here I'm going to show you what the kinds of things are in those relationships I'm going to show over the next 4 slides to suggest to you, I'm not going to convince you, of course, in 5 minutes of a talk, but suggest to you this method is valid. Okay, so for each precinct, we can measure the total number of e-forensics fraudulent votes. Not all votes. If a precinct is fraudulent, that doesn't mean all the votes in that precinct are fraudulent. Could be 1%, could be 10%, could be 90%, could be 100%. So the model will estimate whatever the exact number is with some statistical uncertainty about that. The second thing it estimates down here is F sub TI. So of these total e-forensics fraudulent votes, how many are manufactured? Which is to say you had some people who didn't vote, and yet somehow their votes were counted. You can call this ballot box stuffing or ballot stuffing. I call these manufactured votes. Often in some systems, fake voters are added to the voter rolls, and then fake votes are counted for the fake voters. This happens a lot in Russia. And so that's also estimated by this model, again, for each precinct. If you take the difference between the total and the manufactured votes, I call these stolen votes, because these are votes that should have been counted for another candidate or party, but instead were counted for this one candidate or party we picked that I call the leader, which is the one who can benefit from these frauds. So we get for each precinct, we get a total of the e-forensics frauds, the total manufactured, and the difference is the number of stolen votes. Okay, so really? So let me show you how I'm checking this. So I have a very long manuscript. By very long, I mean like it's 1,000 pages, so I'm not going to get all that right now. So here's just a few examples of how I chose to establish basic validity. Frauds are essentially unobservable. Some people define frauds as unobservable, hidden. Not necessarily people can cheat right in front of you and be proud of it. But what I'm doing here is trying to establish, this one right here, trying to establish, do these e-forensics frauds and e-forensics fraudulent votes, do they measure malevolent distortions of electors' intentions? One way of assessing this is to compare to election courts' decisions, and I'm going to compare to the decisions in these 3 countries, France, Mexico, and Uganda, where the court evaluated claims. In France, they evaluated claims about legislative elections to the National Assembly. Here I have data from 2017. You get same results if you apply them to data from 2012. And here they decided in France, you might think, oh, France, beautiful country, no fraud. Well, they annulled 8 of 577 elections in that. The whole district, they annulled the election. So I'm going to see whether the e-forensics estimates, which are actually estimated using the so-called bureau level data, which are basically like ballot boxes, up to about 250 voters in each of these. Does that predict, match, is that associated with the court's decisions? Okay. And the second one is Mexico, where in the Mexican case, they didn't annul the election, but they did annul the results in 716 casillas, which are ballot boxes. Again, up to about 750 votes in each of these ballot boxes. These are literally just ballot boxes. And they had 130,000, 131,000 They annulled 718 of them. And the question is, do the e-forensics estimates for these ballot boxes match the court's decisions to annul? Okay. The third one is Uganda case, and this is the most recent one I've got here, where in 2006 there was a challenge and there were 355 complaints, malpractices is the court's term for this, about polling stations out of almost 20,000 polling stations, and they affirmed 355 of those. So I want to see whether those affirmations are related to the e-forensics estimates for the frauds, e-forensics frauds in those polling stations. You might guess the answer is yes in all the cases, because otherwise I wouldn't be talking to you about it, because this is my own talk. But anyway, there are some examples I have where it's not so nice, but these are the really nice ones. And they're not, the ones that aren't so nice are complicated, not contradictory really. So these course decisions are procedural. I mean, these are legal procedures. And so, of course, they're law, so process, what they're talking about. But they refer to quantitative things. In a couple of cases, they refer explicitly to the margin in the either ballot box or in the district, and they're really concerned whether the amount of fraud is bigger than the margin, even though they don't really give quantitative models at any point. They're sometimes talking about other kinds of things, but it's not unreasonable to say that you can use these judgments to test e-forensics, even though I don't think the courts are a good way to test statistical models, because these decisions were accepted by the public and even by the candidates whose districts were annulled. They complained, of course, but they didn't riot, they didn't demonstrate about this. So these judgments were accepted. And so I think that's a reasonable validation. Okay, so I'll just go really quickly through these. These are logistic regression models. There's some statistical model. The only thing you need to know about those is that these are the coefficients which express the relationship between the e-forensics fraud here. This is the manufactured votes, stolen votes, and total frauds. And this is over the margin in the district, +1 in case it's tied. And so here I'm aggregating the frauds estimated for each of these bureaux for all the ones that occur in each district. And the main thing you need to know is all these coefficients are positive. So if it's positive, it means that more frauds, there's a higher probability that the court decided to annul the district. And you can see for all three types of frauds here, yes. And there's nuance. I could spend more time. These are really big effects because of the range of the variables. So in France, even though it's like 99% no fraud in France. So I first saw that and I thought there's no fraud, but it turns out the ones that are there are really related to these decisions. In Mexico, similar thing. Now it's again these 719 ballot boxes out of 130,000 or something like that. And you can see positive coefficients for the relationship. The court really paid attention to the margin in each ballot box. They wanted to see that the defect was more than the margin in each ballot box, which I thought was a really strange criterion in Mexico, but all the things are positive there. In Uganda, here we don't have a denominator because they don't talk about that, but you can see that the raw frauds themselves, manufactured, stolen, and total, are strongly associated. And here, especially these AIC statistics, this is much smaller than these two. So it's really the stolen votes that the court is responding to when they're affirming these malpractices, to use the court's decision. So in these three contexts for these courts, very different courts, sort of similar time within a 20-year period, very strong associations between e-forensics frauds, which is this fancy statistical thing out of just this bare data, and the court's decisions, which involved lots of witness testimony and things like that. Okay. So let me talk about estimating it. So I showed this example from 2011 just a moment ago, and I pointed out that the fingerprints went away because I don't have my laser pointer thing here. The fingerprint kind of went away here, and so it's kind of brittle to talk about anomalies, but if you estimate e-forensics for this example, here's what you end up with. You end up with a lot of frauds. The probability of fraud is more than 20%, about 20%. The number of frauds total is over 300,000, and the total votes for the winner is like 5 million, so that's a high proportion. Number of polling stations that have frauds is like almost more than 4,000 out of about 20,000, so almost 20%. Whatever that is. So that's a lot for that one. I'm not going to spend much time on this one exactly because we have the court decision about the 2006 election. So here are these plots for the 2006 election. This one is the original data, has the same kind of, quote, fingerprint as the 2011 election had. taking away not province fixed effects, but district fixed effects of more districts, and I have that data in this year. And so you can see, again, the fingerprint kind of visibly went away, but the course decision is supported because overall, there are 362,000 more or less. Here's the credible interval, so it's roughly pretty tight estimate. So even though you can't see anything, I mean, I don't know, maybe you can see the fraud in this picture here, but it just looks like a nice plot to me. The model pulls out, what do I want to do with this? The model pulls out all these frauds, and it also identifies the number of polling stations here, 4,500, 4,600 polling stations that are fraudulent out of 19,000. So that's 4,600, 4,500 out of 19,000, 5% or more. And so the court is responding to the value you get for not this aggregate total here. Oh, too many buttons. How about this one? Okay. Not this aggregate, but for each polling station, we have an estimated number of frauds, and that's what was being related to the court's decision to affirm these malpractices. Okay. So here's a key example, and it's too small to see these numbers in the room here, but these are incremental frauds, and incremental frauds are smaller than extreme frauds. Extreme frauds are almost always, I will say, related to malevolent distortions, based on some work I did to apply this model to elections in Germany as my basis for saying these kind of things that I'm saying right now. Incremental frauds may or may not be related entirely to malevolent distortions. And to be very brief about it, the key fact is whether the signs of these fixed effects for the fraud's magnitudes, because these are particular coefficients that determine how big the number of fraudulent votes is, if these are positive, then you cannot say, with very unlikely that the e-forensics frauds relate not to malevolent distortions, but maybe they relate to strategic behavior. And the way I'll just illustrate this is imagine two different ways that votes might get switched, right? So imagine an election and you look at it and you say, oh, votes have been switched. Well, maybe they were switched because, someone manipulated the tally, they faked the votes and all that kind of stuff, all these things we'd intuitively think are fraud. Maybe they got switched because voters decided their favorite candidate was not going to win, and so they decided to vote for their second choice. And deciding the candidate's not going to win is strategic because you're evaluating what you expect other voters to do, and then the voters themselves are deciding to vote for their second or third place candidate, most preferred candidate. And so the latter is just strategic voting. That's essential to democratic politics. The former examples are fraud, and those we don't like, okay? So the problem is that e-forensics can pick up strategic behavior, but not if these coefficients are positive. Okay, if they're negative, then you get ambiguities about whether it's picking up strategic behavior or picking up frauds. Okay, so let me move on and go to an example where this ambiguity comes up really big. We're in Michigan, but I don't have really data from Michigan for reasons I can bitch about, but I won't do that right now, other than what I just did. And so here's data from Ohio 2004, which I worked on for the Democratic National Committee, so I have a lot of these data because of my work for that. And so here you can see the original data, and here are data where I've taken out fixed effects for each county. They don't look all that different in this case, and there aren't really fingerprints of fraud in this Ohio data, but still we can estimate e-forensics. When we do that, we find that Ohio looks a lot like Uganda in the sense that the proportions here of the probabilities of fraud are about the same. If we go back to the Uganda 2006 data, you can see here's the Uganda 2006, 0.746, 0.228. Here it's 7.7 and 7.225, so pretty similar. There's fewer polling stations. The precincts here only 11,000 versus 90-something thousand. So the number of frauds is not that many. It's only 177,000. But this number is bigger than the margin between Bush and Kerry in this election. So the number of e-forensics frauds, even the lower bound of the credible interval here, which is a 99.5% credible interval. So e-forensics frauds, if removed from the election, would have produced a different winner in this Ohio 2004 election, therefore a different president elected in the United States. Okay, so is that because there was massive fraud in Ohio? Well, I'm going to do two things slightly out of order. Well, I'll do the main thing. I'll do it in order because I don't have time to play around here. So the key thing, which you can't see in this plot, Again, I pointed out these are the fixed effects for the magnitudes of the frauds. And the key signal that maybe it's not fraud, but maybe it's strategic behavior in Ohio is that all the coefficients here are negative. All these incremental fraud, manufactured and stolen vote fraud magnitudes are negative. And so this means that what we're picking up could be due to strategic behavior and not frauds. I mean, maybe there were some frauds or many allegations. I wrote a whole report for the DNC about this and many allegations, so I can talk more about that if you want to hear about it, but I don't think you do. And so here's what it looks if you plot on a map. In red are all the precincts, and these are 2007 precincts that we plotted the 2004 data into because I didn't have shapefiles for 2004, but I had the addresses for the precincts. That's a lot of fraud. My RA, when he saw this plot, kind of gasped. He's in Ohio. He said, okay. So I said, calm down. All right. So the question is, are these really malevolent distortions of electors' intentions, or is this a case where the model is ambiguous because it's picking up things that are not fraud and saying it's e-forensics frauds? And if you remember 2004 in Ohio, anybody remember 2004 in Ohio? Anybody? Young crowd, okay. So in 2004, there was historically high voter mobilization on both parties' parts. The Democrats had the most votes ever in an Ohio election at that point, and the Republicans also had the highest mobilization at that point. There's a book about Karl Rove, there's several of them. This one is called The Architect, and if you look up the book about Karl Rove called The Architect, it has a long section, maybe 100 pages, that talk about the way that Karl Rove, especially, because the leader in this case is Bush, who had the most votes in Ohio, so he's benefiting from these e-forensics frauds, says that Rove used evangelical churches to gin up turnout for the Republican Party and other religions, but especially that, okay? So what we did here is to try to find where these churches are. The other thing you note, see the cities are kind of hard to see here. Here's Columbus, and here's Cleveland, and here's Cincinnati. So let me just show you another anomaly that comes up. So if you look at Columbus, you can see that downtown Columbus here, there are no e-forensics frauds pretty much. These areas in cyan are places where the precinct has more than 50% African American, so they're not attracting frauds. If you look at Cincinnati here, you can see these green ones are extreme frauds, the rest are incremental frauds. But again, where there's cyan, there's not many. So the punchline is we located 41 mega churches as of 2004 where they were on Earth, addresses. And you can't see this at all on this plot, but there are some right next to Columbus. This little blue thing here is 3 evangelical churches. This one right here is one that a cookout is mentioned in the architect's book at this particular church. So we found that one and 44 of the others around the state. The magenta colors here, it's kind of hard to see the distinction here, but these magenta colors are places that are close to, within 16 miles of a megachurch. And it's completely disappeared the cases where they're darker, where there are also e-forensics frauds. The question is, do you have more frauds in places that are near a megachurch, right? Because that would be compatible with the mobilization through the evangelical church network, getting people to go. And it's strategic because you're going to vote if you know your neighbors or your fellow churchgoers are voting. You show up at the cookout or the picnic or whatever, and so it's really strategic. And the answer is yes. Look at the last 2 columns in this, the last 4 columns in this table here. You can see the difference here is, was it near a church or not? And did it have frauds or not? And you can see that there's a 0.04 difference increase in frauds, e-forensics frauds, near a megachurch. And if you do a slightly different calculation that are near these heavily African-American areas, there's again a 0.04 difference increase in frauds. And these numbers down here tell you it's statistically significant. So you can find that the frauds are related to the presence of these megachurches. And we know from the stories about that election that Karl Rove used the evangelical network to mobilize. And so it's plausible that the frauds at least are picking up partly strategic behavior, maybe entirely strategic behavior. I don't know. And so all of this is not fraud, at least, and so probably maybe all of it, at least some of it, is not really due to frauds. And in my book chapter about this, I say it wasn't big enough to have changed the election outcome. So my last slide here is saying that e-forensics frauds and e-forensics fraudulent votes I think these examples I just showed you say that it is measuring malevolent distortions of electors' intentions, which has been a miracle to me that I worked very hard for a number of decades to produce. E-forensics was not a Biden, no. Anyways, just I said I worked for decades on this, which is kind of true for this project, not this particular model. E-forensics can be ambiguous, however, so it's disappointing in one way that it's still ambiguous in that it can respond to strategic behavior, which I just illustrated, lost votes, which I also talk about, but I didn't talk in this talk about it. It has limitations even beyond those, and here are some of the particular limitations that maybe can underestimate frauds. You have to pick a candidate or party that's going to benefit from the frauds. Maybe both sides commit frauds. It can be slow to compute. So these limitations may be fixable in the future or getting a different algorithm to estimate it. But I'm amazed that this works. Just to be honest, I'm completely amazed that it works. I'm 1,000 pages into being amazed, but still, I'm still amazed that it works with this minimal data. And it's at the top of the slide, it says this is the state of the art, and I think it is. But I'm talking, so that's what I think, of course. And so my summary statement is e-forensics estimates are valid but imperfect. The thing I'd back away, even if you're not looking at e-forensics, the thing to ask about any of these methods that people wheel out to look at anomalies or look at anything else is, one, have they adjusted for basic political variables that could maybe explain away the fingerprint or explain away the pattern they're seeing? And second, is the method able to discriminate frauds from strategic behavior, from lost votes, which could be voter suppression or could be the election wasn't close enough to make me participate in it? Many of the methods don't do that. And after this book, I'm going to write about probably some of those and say how they maybe can be modified. But if we're just coming up with some test, we looked at the data, it looks weird, I'm claiming fraud, then at least it's probably not clear whether what they're seeing is fraud or just an accident or just a pattern that will go away if you just apply basic political science to the data. I'm going to stop. That's it. Thanks. Oh, one last slide is the references. Thanks. Questions?
Forming this method, how quickly can you turn around a result if you have the information available? I sense that Michigan was not very cooperative in terms of providing information, but in terms of in this contested atmosphere, everybody wants information like now. So how quickly could you come up with a conclusion if you had all the information?
Yeah, I mean, the problem with Michigan is that it's hard to get the voter registration data at the precinct level, and I can say more about why that was difficult, but it's still hard if anyone in Michigan is listening. Because if you have all the data ready to go, then it depends on how many precincts there are. So I have data from like Ohio with only 11,000 something precincts, and it just takes a couple of hours, which is still a long time. If I have data from like Indonesia, where there are like 600,000 polling stations, it can take a week or more. You can do a random sample and get it faster. So it can take at least a few hours. Sometimes it can take a couple of days. For U.S. states, usually aren't that big. And so California data can take maybe 5 or 6 hours to estimate it, okay? Having the data, you can't just assume that, because it takes a lot. Even if the data are posted online, you often have to clean the data, and I've done this like a million times for data sets. Not typing them in anymore, but I've done that as well, which is why I'm not going to do Michigan. I'm not going to type in data anymore. But cleaning the data is a big part of it, and deciding and finding in different languages, what things mean. But it's not instantaneous, and it can take a few days, and it's slower than the rate of the internet, of course. But I think to get the right answer, it's worth waiting for. I haven't focused on speeding up the algorithm yet because I want to see what it's worth doing. I kind of think it is now, but I'm still not going to. I'm going to get the book done, and then someone else can find faster ways to estimate it. The core of the model is 2 or 3 features. 3 features or maybe more. Okay, the key 3 features are the finite mixture part, and this comes from Klimek et al. And this is to say that each precinct can be one of 3 types. It can come from 3 different data-driven processes, or whatever word you want to use for that. One process is there's no fraud. The second process is there's incremental fraud. And the third is there's extreme fraud. And those terms, incremental, extreme, come from Klimek et al. And extreme fraud is bigger than incremental fraud in terms of the magnitude. So we need to identify for each precinct what type it is. And these aren't labels that are there, so the statistical model uses Bayesian techniques to estimate the probability, and the one that fits the best is the one it's classified as. The second thing that has to happen is there are 6 equations that express how the votes get distributed. The first 2 equations are just basic political sciencey looking models for turnout or abstention really, but you can think of it as turnout, and for the votes for the leader, or the most candidate with the most votes is the way I have the convention. You can pick whatever party you want. Those 2 just look like standard political science formulations. The next 4 have structures where you take part of the votes that should have been abstentions, and you have a proportion of those that are counted for this leader party or leader candidate, and that's just a parameter that needs to be estimated. And you have another part in that same, each of these 4 equations, that's taking the votes that should have been for the candidates that aren't the leading party and count some proportion of those for the leader. And again, all these things need to be, these are not related to any other observables. It's just the Bayesian model has a way, and this is the third part of it, there's this algorithm called Metropolis Hastings. It was mostly invented in the 1950s. Thank you, Ed Teller. It was part of developing the hydrogen bomb, so there's that. Hydrogen. Anyway, the second H bomb, helium, okay, the big one. So Metropolis Hastings is an algorithm that can basically put down an arbitrary mathematical structure in its way of discovering what's the best version of that structure that matches the data. And so the miracle of that algorithm, which has lots of theorems, has been widely used in statistics since the 1990s when computers got big enough. That's what is estimating these unobservable latent features from the data. And I have ways of testing whether the estimation is good or not. And all the ones I showed you here are good estimates. And so that's where it comes from. There's my interpretation about Ohio and all that comes from background knowledge of me as a political scientist. I know a lot about Ohio. I don't know that much about Uganda. But what it means is where the large part of the work has been going on and will go on entirely. The more you know about the politics and about what goes on there, you can better interpret whether it's strategic or lost votes or voter suppression or something else. But even there are signs from the model that give you a hint, like those negative coefficients I mentioned, indicating the strategic behavior that's ambiguously picked up by the model. So I was talking to my colleague of mine who said, how does it work? And I was trying to explain to him, it's just math, it's just statistics. You have to believe the statistical theory that's developed over the last 50 years is giving you the answers from this model, and you can critique the model, and it may turn out that the model is no good. It has limitations, as I've said, so hopefully it'll be replaced by my grad students or somebody else attacking me eventually, maybe me if I'm fast enough or if I live long enough. But that can be improved, and the big ambiguities there hopefully can be resolved by having a better model.
Hi, my name is Brandon Tinsley. I'm the national politics reporter at Capital B News. Given the decades that you've spent sort of thinking about
It's only 2, sorry, exactly.
Only 2. The 2 decades that you've spent thinking about sort of the meaning, the substance of fraud, of claims of fraud, I'm wondering, for people who work, for journalists, for people who work for more public-facing audiences, how would you say that we can improve sort of the discussions that we have about fraud, especially as the election gets near, but how can we have better, more informed, more precise conversations about fraud?
One thing that I don't know about that is my concluding chapter has to be about is the balance between procedural frauds and what I call realized frauds. Because I've used the model on hundreds of elections, 600 elections, something like that. And often you find that the number of frauds, e-forensics fraud estimated, is not big enough to have changed election outcome. Or like in Russia, Putin got a lot of votes. There's a lot of fraud there, as much fraud as a model could possibly measure, but it's still not enough to have changed election outcome. But there's, assassinations and everything else is wrong. So one question that is beyond just statistics is what is the balance in the enough votes to have changed election outcomes? So assume the model is perfect, which is not. But if that wasn't big enough, what if you had a lot of procedural defects and there was a lot of fraud, but is that a reason to overturn the election? I don't know the answer to that, but I suspect the answer is yes. Because in France, they have this standard where if there's even a hint of anything going on in these close elections, they'll overturn it for reasons like they had a legal Facebook page. You see some decisions like that. But that's a question that I don't know that journalists can maybe probe lawyers and courts about. Are you making a judgment just you didn't file the right form, so we're going to overturn the election? Or are you making a judgment that the outcome was wrong? And until now, there wasn't really any technology to be able to answer that last question. Now, this is still ongoing research, so I can't say I have the answer that's going to be done and dusted here. But it's valid at least to use this method to start to get an estimate of is the election outcome correct. Like in Florida, I wrote about that the wrong man is president paper and argued there were more votes than the margin. Of course, there's only 500 something votes, so almost anything was big enough. But if it's not that, then that's a hard question that lots of explorations could explore. The other thing is if you have people alleging fraud, of course, you want them to have some evidence and not just fantasies or denying the evidence before their own eyes. And then ask them, what is this evidence of? Right? Is your evidence really sharp on votes being wrongly counted or cast because of intimidation or misinformation or something? Or is it just the procedures were wrong, or you just think it looks weird? So just sharpening the discourse and the questions that are asked to people claiming various things. Or on the other side, we need evidence to support elections being accurate. And risk-limiting audits are mainly about that, because hopefully they don't find discrepancies between the tallying mechanisms and a manual recount. And we can't just trust the machines. We need to verify the elections. And those are usually presented as a positive spin. Because you find a discrepancy, it doesn't tell you why it was wrong, it just tells you there was a mistake there, and presumably the hand recount will fully address it, but then you might be worried about the election more broadly. Does that get at your question?
Sorry, Joseph, I'm with Politico. I think you may have answered this already, but it may have went over my head. I'm wondering if you could tell us some of the common indicators of fraud at polling stations and exactly how it's validated.
Well, I guess the question there is indications of fraud. Again, I would sharpen the way you think about it. Indications of procedural defects or indications of the vote count being wrong. And indications of procedural defects are many and varied, like a 5-hour line out the door tells you there weren't enough voting machines or something went wrong, so people are having a very long wait, so people can't stand in line, and so you get people reneging, and that's before your eyes, something went wrong. Other things about votes being refused, people are registered, but they're not, they say they're registered, but they're not on the poll, so you see them complaining about their qualifications to vote that they have there. Or you have challengers there who are intimidating voters, and so you can just see things that procedurally or either don't look right or legally, because you have the details of what the legal process should be, you can see things being done incorrectly. And the procedural frauds have that feature that if you know what the process should be, you can see what's going wrong. Usually, of course, they could be in the back room cheating. You can't see that, but you can see that. So many observer groups have reports about even American elections these days or others, and you can consult those to see what kinds of things they look for. Pippa Norris's book that I cited that's on here somewhere down here has 300 pages of details of the kinds of things well before the election through the after the election period that people should look at to think about whether the election overall, not just in each precinct, had a matter. So the procedural side is very well developed. For the vote count side, I'd say the only mechanism besides my still not quite published and not perfect e-forensics method, risk-limiting audits is a way that you can check by manually tabulating random samples of precincts to see whether the tabulation, if you hand count the paper ballots, which have to be cast on paper to have full validity, do they match the machine tallies? So that's something that can be done, again, not for a single precinct, but for all the precincts. You can do it for one, but that's not really telling whether the result overall is there. Other kinds of diagnostics like digit tests and all those other things I mentioned, to be blunt, I don't think they work. Sometimes they show things but they can have false positives, and I just don't think they work, and they're not rich enough in the way they've thought about the data. So I'd be skeptical of those kind of indicators, even though I'm the author of some of those 10 or 15 years ago. So eventually, hopefully, we can get enough data to just run the eForensics model or whatever model succeeds it and tell what it says about these. But also, when the book comes out, you'll see that I have strong reason to believe it systematically underestimates the number of frauds. It also doesn't tell you it's an eForensics fraud. Well, what happened? You know, and it doesn't tell you that, it just gives the estimate for this thing. It could be a long list of things that went wrong. So the way of development, once this method gets invented, which is now being invented, I'm trying to get it out, and then improved, and then we can have discourse between procedural and realized and how that goes to a judgment of whether people should trust the election or not. And I haven't invented all of that, but hopefully the journalists and everybody else will help have that public discourse over the next 5 to 10 years so we'll get a more sophisticated understanding of how to do that.
Yeah, Sean Waterman, freelance journalist. You said something just then and earlier that implied that a hand count is the most accurate way to check the vote tallies. But I think, unless I misheard him, one of the speakers in the previous panel said that actually hand counting was a very inaccurate way of counting votes. So I'm confused. Is it more accurate to tally votes by hand? Or is that just because in a risk-limiting audit or one of these other contexts that you've referred to, there's a much smaller number of votes?
What I meant to say is that the advocates of risk-limiting audits believe that hand tallies should be taken as the standard compared to trusting a machine tabulation. And so the advocates of that method do recognize that hand counts are imperfect and slower and all the rest of it. But one feature that does help with the risk-limiting audit versus, say, a full recount, full manual recount, can be that the smaller number of ballots that one needs to tabulate for a whole election, like you have a election with like 16 million votes, you can get away with a few hundred manually tabulated votes in a risk-limiting audit as opposed to a full manual recount. It could be that that process could be done because you have 3 counters and other ways to make sure that the counts agree and all those kind of things, not just a single counter. You can boost the resources devoted to that manual recount to make sure it's as accurate as can be, even if it will never be perfect. So this is a view that I'm not saying I personally believe, because I certainly know that manual tabulations can be full of mistakes. But their belief is firmly that the machines, which can be arbitrarily tracked by software that's untraceable, so you want a method that the key term of art is you want election tabulation to be software independent, which means it doesn't depend on software and it doesn't have undetectable errors that can't be fixed. Arguably, you can count the ballots again and again and eventually get to a conclusion within a couple of votes of what it is. But if a virus has hacked your machines in a way that changes all the votes from, as a video goes around, you've probably seen it, from George Washington to Benedict Arnold or something like that, Benedict Arnold, you can't really tell anymore because it's all electronic. Then their argument is it's better to have voting cast on paper, not even ballot printing machines. They dogmatically say those aren't even accurate, like in Georgia. But the voter casts their vote, and you count it manually. Voters casting their vote on paper make mistakes at a certain rate. The minimum rate there is about 0.075 probability of that happening. So nothing is perfect. But their view is it's better than the machine relying on the machine. Not that it's perfect.
With that, I'm going to have to close this session. I want to thank Professor Mebane for coming here, and I think he is destined for either a series or at least a show on CSI.
CSI, yes.